faithfully sharing insights from great books worldwide. Hi, this is Sally's Book Talk. Today I'm diving into the book, The Molecule of More. How much do you know about dopamine? And in what situations do you most feel dopamine being released? Feel free to share your thoughts in the comments. Some might say eating sweets or falling in love, but how long can a romantic relationship last? Why does that person you fell in love with at first sight, deeply infatuated, lose their appeal in just a few months? Why can't we resist sweets?
Even people who are very persistent in work or studies often fail at diet plans.
The manipulator behind these questions is dopamine, the star of this book. Dopamine is a chemical in the brain. Its form is simple, made of carbon, hydrogen, oxygen, and nitrogen, but this single molecule produces very complex results. Many creatures in nature secrete dopamine, but no creature has as much as humans. As the authors say, this dopamine molecule tells the whole story of human behavior. Human behavior is very complex. To study the patterns of human behavior, many universities offer a comprehensive discipline called behavioral science, with foundations in anthropology, sociology, psychology, physiology, biology, and more. It can be said that those who master behavioral science understand both science and human nature.
One of the authors, Daniel Lieberman, is an expert in behavioral science. He's the Deputy Director of Clinical Affairs in the Department of Psychiatry and Behavioral Sciences at George Washington University in the U.S.
An honorary member of the American Psychiatric Association, he has published over 50 research reports on behavioral science. The other author, Michael Long, is a professor at Georgetown University. He was the director of writing at the School of Continuing Studies and is an excellent speechwriter, having written for congressmen, governors, diplomats, and presidential candidates. After publication, this book was selected for the main list of most beautiful science readings by Global Science magazine in 2021 and won the American New Era Independent Book Award. Dr. David Eagleman, a neuroscientist at Stanford University, and Dr. Vilya Ramachandran, a neuroscientist at UC San Diego, both highly recommend this book. Next, I'll interpret this book in two main parts. Part 1, how does dopamine work? Part 2, how does dopamine affect us? First, let's talk about how dopamine works. Dopamine's role in human behavior is tied to its two key characteristics. First, it manages expectations for the future. Second, dopamine is greedy and never satisfied. At the start of the book, the two authors present a revolutionary insight. Dopamine isn't a pleasure molecule, as many believe. Instead, it's why we don't stay happy all the time. We feel pleasure because we experience satisfaction in the moment. In the past, some scientists called dopamine the pleasure molecule because studies found that when dopamine is produced in the brain, people experience feelings of pleasure. When dopamine activity drops in the brain, the pleasure feeling fades, but this only shows dopamine activity is linked to pleasure, not that it creates pleasure. To figure out how dopamine works, Professor Wolfram Schultz, a neurobiologist at the University of Freiburg in Switzerland, conducted a study. He implanted microelectrodes in areas of the monkey's brains where dopamine clusters to monitor dopamine activation. Schultz put the monkeys in a setup where they could see two light bulbs and two boxes. One light indicated food in the right box. The other light indicated food in the left box. At first, the monkeys didn't know the connection between the lights and the food. When they found the food, dopamine cells in their brains were activated. But after some time, the monkeys figured out the pattern of the light signals. At that point, the timing of dopamine release shifted, moving from when they found the food to when they saw the light turn on. This experiment shows that dopamine release is tied to surprise. When the monkeys knew that the light meant food, their surprise came entirely from the light turning on, not from finding the food. Dopamine's impulse comes from anticipated surprise. So dopamine isn't a pleasure molecule, it's a response to possibility and expectation. It's more accurate to call it the expectation molecule. Only unexpected rewards stimulate dopamine release. bringing excitement. Scientists call this pleasure from novelty, reward, prediction error. We're constantly predicting what will happen. For example, expecting to get paid before leaving work today, but then not only receiving the salary, but also discovering an extra bonus this month.
This kind of joyful prediction error stimulates dopamine, prompting quick action.
That's because this unexpected bonus brings excitement as unforeseen good news. Dopamine is the expectation molecule, and one of its goals is predicting the future. When unexpected rewards appear, it alerts our brain to quickly learn something new has emerged. Remembering it might be useful later, dopamine reshapes the brain to turn surprises into predictable events. If I keep receiving this bonus next month and beyond, it'll stop being a surprise, won't bring reward, and prediction errors won't excite anymore. Dopamine is future-oriented, but we can't live constantly pursuing the future. We must also learn to enjoy the present. This brings us to the here and now molecules that counter dopamine. These present-focused neurotransmitters include serotonin, oxytocin, endorphins, the contentment molecules. Dopamine brings pleasure from anticipation, while here and now molecules deliver pleasure triggered by senses and emotions. In other words, dopamine drives us to passionately pursue things, and here and now molecules give us the ability to appreciate them with contentment. When lovers first fall, their passionate romance is dopamine-driven. They idealize each other and imagine beautiful futures. Dopamine spurs the couple to strive relentlessly, turning imagined futures into reality. But when returning to reality, dopamine gets suppressed. Here, they need not pursuit skills, but companionship skills to maintain love. This ability is here and now, molecule-driven, experiencing small, real joys through senses and emotions to transition to love's next stage. In companionate love, high dopamine suppresses here and now molecules, fueling exploration but blocking present moment joy. Elevated dopamine inhibits present-focused neurotransmitters, preventing enjoyment of now and maintaining stable long-term bonds. That's why romantic love struggles to last. That person you fell for at first sight loses their appeal within just a few months. For dopamine, having is boring. It's the process of obtaining that's interesting.
And dopamine is never satisfied. It always craves more surprises.
That's precisely why this book is titled The Molecule of More. And dopamine's job is to make us maximize future resources and pursue better things. From survival and evolutionary perspectives, dopamine constantly works to sustain life. It acts like an alert system, perpetually reminding us to notice survival beneficial things. Dopamine creates that feeling of wanting. Essentially, it's telling us there's important resources here.
When beneficial resources appear, dopamine urgently pushes us, whether we like it, need it, or not.
Don't overthink. Don't get it now. Anything life-sustaining can never be too much.
This explains why dieting is so tough. Food is critical for survival, even when you're not hungry at all. When you pass a food stall and smell it, dopamine activates, creating intense cravings. So failing at dieting doesn't mean you lack willpower. It just means your dopamine is more persistent, always focused on its mission. Dopamine is greedy and impulsive. Its cravings may drive us toward things we don't even like impulsively buying an expensive dress you'll rarely wear. If the dopamine reward circuit gets overstimulated into pathology, it can lead to addiction or harmful behaviors like binge eating, drugs, or gambling. The authors share an example of dopamine and technology combining to create addiction. A 15-year-old boy accidentally seeing a pornographic image online, instantly activating his dopamine reward circuit and driving him to seek more. Back then, slow internet meant long loading times and milder content, so his dependency didn't become full addiction. Later, faster internet allowed instant images and videos. The result is that the dopamine circuit gets increasingly stimulated. His tolerance for pornographic stimuli grew, and milder content could no longer satisfy the greedy dopamine in his brain. Driven by dopamine, he became addicted to pornography and couldn't break free. The dopamine desire circuit is incredibly powerful. Fortunately, our brains have evolved another dopamine circuit that complements the desire circuit. The control circuit's purpose is to rein in the impulses of the desire circuit and channel that primal energy toward beneficial outcomes.
The desire circuit is like an excited child, curious about the world, energetic, wanting everything.
But our brain knows well that merely wanting doesn't get us what we desire. We need planning to achieve. The control circuit acts like a calm, rational parent who assesses, calculates, makes reasonable decisions, and devises strategies. Both circuits start in the same brain region, but the desire circuit ends in excitement-sparking areas while the control circuit leads to logical thinking regions. If the control circuit is weak, like a child without parental supervision, we act impulsively, pursuing immediate wants without considering long-term consequences, which severely impacts our lives. For example, people with ADHD have weaker control circuits, making it hard to focus on complex tasks. But an overly strong control circuit isn't good either. Excessive dopamine in the control circuit can lead to addiction to achievement. Some people strive relentlessly for achievements but can't enjoy them.
Once a goal is achieved, they must immediately seek the next one.
Neither circuit should dominate. They must collaborate to achieve dopamine's ultimate goal, maximize future resources for a better tomorrow. Now that we understand how dopamine works, in part 2, let's explore dopamine's impact on us. This impact falls into two categories: effects on individuals and on human society as a whole. First, let's discuss dopamine's impact on individuals. Future-oriented dopamine gives us the most powerful force on Earth. To judge creative thinking, the key is whether one can break free from preconceived mental models and see things in entirely new ways. Models are powerful tools. Our world is complex. Without models, we'd be completely lost. For example, I know nothing about sports cars and have never seen a Ferrari, but I immediately recognize it as a car and understand its function. That's because I've seen many types of cars, so my brain has an abstract model of what a car is. When I see a Ferrari, even without knowing the specific model, I instantly match it to my mental car model. This abstraction saves enormous relearning time. What it is and what it does? Usually we don't notice our brain's modeling process. It automatically builds and updates models through daily activities and learning, guided by dopamine, invisible and intangible. To build models, we must think about things that don't exist now but might in the future.
In other words, we must use imagination. And imagination's source is the dopamine control circuit.
It provides tools for understanding, analyzing, and model building. While imagination builds models, creativity breaks them, both dopamine-driven. Dopamine lifts us beyond the physical world into deeper realms of abstract thought. Like a child toppling their sandcastle, dopamine demolishes its own models, letting us restart and find new creativity in familiar things.
Scientists call dopamine-related processes or behaviors dopaminergic.
Some people have more active dopaminergic circuits than others. The authors call the personality traits these people exhibit a dopaminergic personality. Active dopaminergic circuits express differently. Hyperactive desire circuits may cause impulsivity or insatiability, constantly seeking new thrills. While those with hyperactive control circuits stay calm in chaos, they might seem cold-hearted or even cruel. What other traits might a dopaminergic personality show? Positively, dopaminergic personalities love abstract thinking, have rich imaginations, and exceptional artistic talent. They're adventurous novelty seekers, highly adaptable to environmental changes. They're very smart and learn faster than average people. However, they also have clear weaknesses, like struggling with complex relationships and being intolerant of boredom. Regardless of what traits a dopaminergic personality exhibits, they all share a common point: excessive focus on future value at the expense of present happiness. And D, this is the conflict between dopamine and here and now molecules that the book repeatedly emphasizes. Is it possible for these opposing molecules to cooperate? In fact, most of our brains haven't collapsed due to the conflict between dopamine and here and now molecules. This shows that dopamine and here and now molecules have learned to cooperate through evolution. And here and now molecules enable us to focus on reality and what's happening now maximizing the flow of information into the brain. This rich sensory information activates the dopamine system, maximizing its ability to create new plans. Without the help of here and now molecules, dopamine struggles to predict the future and achieve its goal of maximizing future resources. For us, as long as dopamine and here and now molecules stay balanced, we can enjoy the happiness from their cooperation. What happens once balance is lost?
Excessive dopamine leads to high energy and over-focus on achievements, like becoming a workaholic who can't enjoy life.
While excessive here and now molecules lead to a slacker state, like just wanting to lie in a rented basement, smoking, drinking, and gaming. Clearly, neither lifestyle is the happy life ordinary people pursue, so keeping the two molecules balanced is very important for us. How can we maintain the balance between dopamine and here and now molecules? The authors offer some very practical advice, such as finding something you're skilled at and immersing yourself in it. From dopamine's perspective, when you master something, dopamine achieves its goal, using all available resources to gain maximum rewards from the current environment. At this point, the hyperstimulated dopamine takes a break, no longer fighting the here and now molecules, and you experience satisfaction, enjoying the immersion. The authors also suggest spending more time in natural environments. In complex, rich settings, we tend to receive more sensory information, which better activates the dopamine system. The most complex and abundant environments around us are usually natural ones. Nature offers countless details to explore, full of changes, making it the most inspiring environment. There's also an environment-independent method everyone can try. Engage more in creative activities. Creative activities are the best way to combine dopamine and here and now molecules, like painting, crafting, flower arranging, and so on. These activities require both brain and hands to create, imagination and planning from the mind, then hands executing the plan. And this process, dopamine-driven abstract thinking and here and now sensory experiences, combine perfectly. So even though these creative activities won't make you money or help your kids get top grades, they truly bring joy. Finally, let's look beyond the individual level and consider dopamine's significance from human development perspective. For humanity, dopamine is both a blessing and a curse. Greedy dopamine pushes us to want more. From this angle, it's the engine of human progress. Modern humans originated in Africa and gradually migrated worldwide. This movement was vital for human survival. If a species concentrates in a small area, natural disasters could lead to its collective destruction. Dopamine drives humans to pursue more. Our ancestors included high dopamine adventurers who, dissatisfied, left homelands to explore the unknown. In modern society, dopaminergic personalities are more likely to leave familiar environments, emigrating abroad, seeking new opportunities. The United States is an immigrant nation. According to a research brief from George Mason University's Institute for Immigration Studies, from 1901 to 2003, Americans won 42% of Nobel Prizes, more than any country. Notably, a high proportion of these laureates were immigrants. Key new economy companies like Google, Intel, and eBay were also immigrant-founded. As an immigrant nation, America's achievements can be called dopaminergic achievements. Dopamine not only enabled human survival on Earth, but gave us imagination, creativity, and planning abilities that brought prosperity. But never stopping dopamine also brings humanity the risk of destruction. Our technological progress is advancing too rapidly. Brain evolution requires immense time, yet dopamine can't comprehend that for a species. More doesn't mean better. Relentless advancement may lead us into the abyss. For example, highly dopaminergic scientists can't stop themselves from creating weapons of mass destruction. Highly dopaminergic rulers can't restrain their greed for power. Another common example is our consumption of Earth's resources. Every nation wants to develop faster than others. This frenzied competition results in industrial activities damaging Earth's environment, accelerating climate change. Humanity ultimately pays for its desires. Now you've met the greedy dopamine, the expectation molecule that loves unexpected surprises. It's the desire molecule, always wanting more, Let's recap this book's key insights. Dopamine-producing cells make up just 0.005% of the brain. Yet the dopamine they generate profoundly impacts us. Our emotions, impulses, imagination, creativity, all dopamine-linked. Humanity's survival and potential destruction both tie to dopamine. Dopamine's mission is to drive us toward maximizing future resources and pursuing better things. Our task is overcoming dopamine's endless cravings, maintaining balance with here and now molecules, enabling their optimal collaboration. To achieve this balance, engage in mastery activities, immerse in nature, and participate in creative pursuits. After this interpretation, have you discovered how to coexist harmoniously with dopamine? Feel free to share your thoughts in the comments. Well, that's the molecule of more. This concludes our book interpretation. Reading notes are below the audio. Until next time.